Hello, this is a short video on how to get your robot to drive distances in centimeters. This is obviously a huge advantage in FLL. As most people know, the motors are measured in rotations or degrees, so being able to drive repeatedly different centimeter distances makes programming much easier and will allow you to create code much quicker. So let's take a look. I am using the same base as both RoboKai teams right now. It just doesn't have all the other top pieces on it yet, but let's just hop right in here. So as you can see, as I mentioned, everything here rotationally on your motors is based on either degrees or rotations. So what does that mean? That means that if we can calculate how much one wheel rotation is, we would be able to convert that into centimeters. So I'm just going to start with coding right away. We'll flip around a little bit and also tell you a few best practices here or there. So because this is code that's going to be repeated often, tons and tons of times on the board, we're definitely going to use a my block here. So we'll start by calling it drive CM. Now, I like to, after my inputs, add a label to, and the reason for that is if you don't add a label, when we go to pull the block in later, it'll be blank. You're gonna have to take my word for it at the moment, but you'll see when we go to pull it in what I'm talking about. So I'm gonna add an input here, and I'm gonna call it distance CM, just so I know what I'm talking about. And here's where the label comes. I name my labels the same thing as my variable basically inside there, but you can do whatever you want. This ultimately right here is the piece that's going to show up. And I'm going to put another input here because we're going to want to control power too. You'll see that as we add PID and other pieces in there that we've talked about a little bit, that you will start getting some very long my blocks where you can feed in multiple variables and do things. But we'll start with a simple one right now. So the next thing we're going to do is power, because we definitely want to control that too. And we'll add a label for power as well. Okay, so the my block is done. We're going to set this over here right now, and we're going to start working on it right away. A best practice is always to set your movement motors, okay? This variable will carry through the rest of the time. Now, we could do it right here. We technically could do it in the my block. I'm going to do it out in the main program loop because no matter what, these motors are always going to be, in my case, A and D. These are my large motors. So once I've defined this, now if I tell it to move, it automatically knows to engage both of these motors. So this is a best practice and it should be used. I would suggest that both teams try to align their ports the same with their robots in case they want to try to share code. As some students have already figured out when they were using the smaller EV3 education bots and going back and forth, this did present a problem. Sensors change, motors change, everything changes. Now there's another piece in here that I like to put in all the time. It's another set movement motors right here. Now what this does is it hits the brakes or it doesn't hit the brakes basically. So at the end of your code, if I have these set to hold position, it's going to lock the robot wheels hard. A lot of times we leave it like this. Very rarely do we float. Maybe we'd want to float if we were coming off the board so it doesn't just slam on the brakes and the robot can kind of coast in case it doesn't make it all the way into the position where you can handle it. But for the most part, most of the time you'd want to do this and just do a hold position. Otherwise, the robot could be in an unpredictable spot because maybe it rolled a couple more centimeters one time, and then the next time you did it, it only rolled 1 centimeter. So this is a best practice. I like to see everybody always doing this and defining things. And now we'll jump into the fun part. So we're going to use a move block. There's different kinds of move blocks in here. What I'm looking for is one that moves in a direction, for a distance, and with power. So pretty much everything. So here it is. It's this guy right here. Move straight for 1 rotation at 50% speed. So we're going to start with that. Now, how are we going to feed stuff into here? Okay, so first of all, power is kind of obvious. We're just going to slide this guy down here, and now anytime we call this block, whatever power I have in here, and this is the percentage it's going to be at. Here's where we need to calculate some things. So we know that the size of our wheel, okay, so I'm just going to show you a little handy dandy tool here. We know the size of our wheel, we know the diameter, so we can calculate the circumference of one rotation. Everybody in our class is using this EV3 basic tire right now, so I'm just going to select it with this tool so we can figure it out. We could on our own. If you've had it in math already, you can calculate the diameter, or you can calculate the circumference if you know the diameter. It's just pi times it. So this thing's going to do it for us, and it's going to do it to a bunch of decimal points. So I'm just going to hit calculate. So basically what this is saying is one rotation is 17.529 blah, 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 blah. Okay. So I'm going to take this math, go back to our program again here. And we're going to do a little bit of math. So we know we just want to move straight for now. We'll talk about that later when we get into using gyros and things. So I'm going to take a math block now, which is underneath my operators. And I'm going to take that and say, okay, so whatever I feed in for my distance in centimeters, I'm going to divide it by that big number. That being said, if I put in 17.59, it's going to go for that many rotations. So we're going to leave this at rotations, move this block in there. Okay, and now we got something here. So basically, whatever I feed into distance centimeters is going to be divided by that, which will convert it into rotations, and we'll have our power here. The code's pretty simple at that point, but extremely powerful. Reusing this over and over and over again, you can do some really powerful things. So let's test it out. I'm going to do 10 centimeters at 50% power. My robot's already hooked up at this moment in time, so I'm going to show you right here. This robot right here is 10 centimeters from the end of this ruler. So let's go ahead and test it out. Okay, you'll see it drove exactly 10 centimeters. Now, you notice my code was still running, and I've seen that happen to you guys too. So let's do something here too. And just as another good practice, let's just end everything at the end of our robot moving. And some other cool things you can do right here. So, okay, we want to go backwards. We can drive negative 10 centimeters. So let's try it. Negative 10, power 50. And there it goes, right back 10 centimeters. And that's it. So we'll start to combine this with more things, but even having this right now, you could already complete some missions. So this is powerful code. Understand it, use it. We've already gone over it in class, so you're already free to use it, but I just wanted to make a tutorial so that people could make it again. And that's it for this session. Thank you.